today's so we're moving into this material where well, what we need to do is we need to use these properties of logs and exponents. And so for some of you, this is going to be a bit, it's a really cool technique. But if you don't have the pre-calc down about the rules, it's really hard to do these problems. So these problems are a lot of the pre-calc for the rules. You have to remember these things. So that's this idea behind this first part of this quiz, is just to kind of review some of the pre-calc here. Okay, so as usual, there's chat in Twitch and chat in oops, and chat in chat in whatever this thing's called. Blackboard Collaborate Ultra. Okay, that was awkward. All right, so this first problem, again, these are kind of reviews from Precalc. These, I didn't exactly pull these from the Precalc book, but they're similar to ones that you were asked on in Smart Lab last semester about these things. So I've got a to the 10th, and I know that the log of a is 5, and I know that the log of b is 2. So what I do, remember the rule of exponents, ln the following rules, recall. Ln of a to the k equals k times the natural log of a. So I pull the 10 out, and I wind up with 50. Now on the second one, recall that, recall ln of xy equals ln of x plus ln of y. So I pulled those out, and you get 5 plus 2. And then you add them together, you get 7, at least this week, right? And then here's another b to the x. Oops. I didn't read this problem right. I thought that was a 2. That would be x ln b, which would be 2x. And then this one right here would be ln of a minus the ln of b, because it's one over the other, and that gives you 3. Okay, so how do we feel about those 1 to 5? This is just a little, and if you don't feel good about the pre-calc, come talk to me. Oops. Yeah, I need to figure that. Oops. So if you don't feel good about the pre-calc, talk to me, talk to one of the tutors. Let's get the pre-calc down. I may have some, I'll dig into my stuff and see if I've got some activities. I think I do. Oh, I do have some activities. So I posted the, Precalc review activity on WebAssign. That was due last Friday for this stuff. So go ahead and pull it. If you haven't done it, go ahead and request an extension and get that done. And then if you go into, if you're still not comfortable with them, there are some review sheets in, if you go to files and you go to activities and you go to module 0 review, there's some stuff about, there's 2 on exponentials. There's one on exponential and one on logarithm in the thing. And the pre-calc reviews, if it says pre-calc review, it says counts as extra credit. It should be in the right category. But remember, I mentioned this before, that the extra credit has to be manually re-imported from WebAssign. So it doesn't actually change your WebAssign grade on Canvas when you do it. And if I'm in the wrong spot, then I need to fix it on the thing. If it's not working on Canvas right now, but again, they have to be re-imported. Okay. All right. Okay. So what I wanted here was for you guys to go get these functions. So what I wanted you to do would be to go on Desmos or grab a graphing calculator or do something and look at these functions for a moment. So these functions are, ln of x and e to the x. And this is what they look like. And ln of x, as you go to infinity, it gets to infinity. It goes very, very slowly, but it will eventually get to infinity. Ln of, then ln looks like this. So as you go towards 0 from the right, you get negative infinity. C and D are both the I should write for A and B. C and D, it's infinity and 0. And there's the kind of justification for that. Okay, so how do we feel about that one, 1 to 5? What those things are asking for? Okay. All right. So what I'm going to do for question 3 is this. I've got pressure and volume both moving in time, which C is a fixed constant. So I need to differentiate this in terms of time. So what I get is the derivative with respect to time of P times V equals the derivative with respect to time of C. So I took the derivative of both sides. Now this thing right here, since C is constant, the right side becomes 0. So the left side, I'm going to do a product rule. I'm going to get the derivative with respect to t of p times v plus p times the derivative with respect to t of v. And that's going to equal 0 because that's a constant. All right, so the derivative with respect to time is just the pressure is dp over dt, and then I've got a v that hangs out, plus a p times a dv over dt, and that equals 0, and I'm done. Now, I can move one of them to one side, but I didn't ask you to do that. All I wanted was an expression related, but I could, right? I mean, this means that dp over dt, right? This is like the stuff that this means. I want orange. I think this is orange. Yes. Excuse me. And this means that what I'm going to wind up with here, if you do some simplification, is this. You're going to wind up with dp over dt equaling, I move this over to the other side, divide both sides by v, negative p over v times dv over dt, if you care to do the simplification. Or I could do it the other way, with putting dv on the other side. But what it means is that they're going to go in opposite directions. You can see that, right? Because of that negative sign. By a factor of P, the current pressure of the current volume. Excuse me. So how do we feel? So the orange is not needed. The orange is absolutely not needed for correctness. In fact, the orange it shouldn't be done. The orange should not be done. It's correct, but it should not be done. But that's the implication of what's going on. Yeah. All right. All right, this last one, the ellipse. Here's the idea. So I'm going to draw my line tangent to the curve. That's this. All right. And from that line, it looks like right, so this would be y equals negative x plus 2 is a guess. All right, now you didn't need to write that. You needed this line. But that's what it looks like, right? Okay, so we did the graph. Okay, so let's do the implicit differentiation. Okay, so what I need is a slope and a tangent. So I need a slope and an intercept. So the implicit differentiation would be d over dx of both sides, x squared plus xy plus y squared equals d over dx of 3. All right, so let's run through this. I'm going to run through it with the sum rule here. This is going to be 2x plus, that's just a power. So I'm going to do this one at the same time. I probably shouldn't have. This is going to be interesting. We're going to go ahead and put that here. Plus, and then this one's going to have a chain in it, but this one's going to be 2y dy over dx. And that's going to equal 0 because the right side is a constant. But this d over dx of the thing in the middle, this is a product. So I need to handle that a little differently. I'm going to wind up with 2x plus the derivative of the first times the second plus the derivative of the second times the first plus 2y dy over dx equals 0. All right, well, that's going to give me the following. That's going to give me 2x. Now, the derivative of x with respect to x is 1. This is going to become a dy over dx. This one stays in x plus 2y dy over dx. And that equals 0. Now, if I want to, I can solve for the dy over dx. But I'm not gonna. I just don't feel like it. The instruction didn't tell me to. It just told me to find the tangent line. Okay, so what I'm going to get is 2 times 1 plus dy over dx, which is slope. Times 1 plus 2 times 1 times m equals 0. Okay, so that's going to be 3 plus 1, 3m equals 0, which implies that m equals negative 1. All right, and then we got point slope formula. Y minus 1 equals, where was I? M negative 1 times x minus 1 line. So that is our answer. Is our answer for part B consistent with the line we drew for A? Well, yes, right? Because our answer for part B was y equals 1, y minus 1 equals negative 1 times x minus 1, which is the same thing as move the 1 over to this side, multiply it out, so I get y equals, and then I add the 1 on both sides, and I multiply it out, and I get negative x plus 1, which is the same thing as negative x plus 2, which is the same. I use this. Oh, I bet there was enough room last semester. I don't understand why there's not really enough room on this one this semester. Probably because I changed the equation. So 1 to 5, how do we feel about that last one? Yeah, so it would be enough to just say they both have the same slope. I went a little bit overboard in my explanation. Okay. All right, are there any other questions about this? All right, so the method for doing these is pretty, it needs, you have to understand the implicit differentiation. But these questions are all generally laid out the same, okay? You've got a beautiful picture. You've got a question that asks you to find the slope of a tangent line. So remember when I talked about math being cumulative, and every test is cumulative because this is like these types of questions are popular on the test. And so what you do is the connection between the slope of the line and the work. All right, so that's the idea here. Usually they'll have a product rule thrown in there somewhere, like the folium curve that I did on Thursday had one, and then those are the types of things that people like to ask on tests. And then this idea of consistency. So, saying the slope and the intercept match, that's good. If they don't match, right, say that. Don't lie. Don't say yes they match when they don't, right? If your work had come out completely wrong, right? Say what you think. Say what's true. And then do a little bit more. Say why they don't match, or, say that they should. So if you wrote here, let's say you were wrong. So for part C, if they don't match, one, don't lie. And two, say they should. Now, in the past, I don't know how this one will get graded, but in the past, if such a question appeared on the test, it did last year, if you say they don't match and that they should, and that you messed up somewhere and your mistake was in here, that's actually worth something. We usually give a point back. Obviously if they match, all good and good, you're good to go. But if they don't match, say they don't match and say that something's wrong. That they should have, that you made a mistake. Because that actually shows more understanding. If you made a small algebra error in here, which is perfectly possible, but then you came back and you said something about it. You said that they didn't match. In the past, we've given a refund point or two for that. Because you actually said something that was very intelligent, right? Not only did you know it, not only did you not lie, it didn't match, but then you went further. So if you said no, they don't match, you would have gotten the point here. But if you said no, they don't match, but they should, and I made a mistake, sometimes you get a little bit more back because you're actually saying something, and you're actually aware of what's going on. You're showing that you're thinking about it and that you understand part of it. Maybe you made an algebra mistake. Does that make sense? All right.